So tonight we have a presentation on microservices testing. Our presenter is Justin Phillips. He is a software engineer here at Ultimate Software. Justin, how long have you been here now?
4 years.
So, long time. Well established, right?
Yeah.
All yours?
Thanks. So, as Philip said, my name's Justin. I've been at Ultimate for 4 years now as a software engineer. I work on a team called Quality Architecture. I think that's what they're called, right, Danny?
Yes. Wait an hour, it'll change.
Quality Center of Excellence, yeah, I'm not sure. So we develop internal tooling to assist with testing. We do some research in new testing techniques and testing software, and also hold trainings around testing, specifically white box and black box trainings. And also do stuff like this, talk about microservices testing. So this is kind of a slimmed down presentation that my boss and I, Tree King, showed first in Star West in 2018, and then Star East just recently. And then he's also been around the world and shown this some of this material in Romania and Tokyo and some other places. I'm not sure where. Yoni, you remember any of it?
I lost her.
Yeah. So he's been all over presenting it, and it's usually pretty well received. So let's go ahead and get started. Gonna keep it pretty high level, but if people have granular questions about different nitty-gritty things with testing microservices, that's cool too. So it's kind of a small group, so good setting for questions. Let's go ahead and get started. So first, I think about 5 or 6 people said that they were working with microservices already, and everyone else was either interested or something else. So the definition I chose from this is from an IEEE conference in 2018 that was held in Seattle. And here it's a pretty loose definition, which is what you'll find all over the place. Like Wikipedia has a few other definitions. And so it's just a variant of service-oriented architecture, where you have a bunch of loosely coupled, very lightweight services that work together to make the application easier to understand, develop, to test, and to maintain. So it's a loose definition. It's not like, okay, microservices are services that are 1,000 lines of code or less, and they have exactly one API endpoint or something like that. It's really loose. Your definition of how small is small, and that sort of thing. There's a lot of usage of domain-driven design and things like that, with subdomains and having domains and how you structure things, but really it's a very loose idea. So some things to note that are different between microservices and monoliths, monoliths being like a big ball of mud or one giant application or one giant binary, is that there's a lot of infrastructure when it comes to microservices. There's a lot of network, a lot of services aside from your APIs and aside from what you'll code out and the logic and stuff like that. And so some of that will look like discovery services, which I like to call glorified cloud-based hash maps. So they're really simple services that you just give a name of an application or a service, and it returns an IP and a port or some type of a location about where that service lives. So that helps your services strive towards the principle of location transparency, which is really important with microservices. You want to be able to take your service, and be able to put it in any environment anywhere. And as long as the necessary dependencies are there, no matter what the network looks like or anything else, they should just work. Next, we have gateways. People use gateways as monoliths too, but this is the main ingress point for your subdomains and your system as a whole. So your gateways route your traffic to the various services and help break up the infrastructure. So if you have like 200 microservices, you probably don't want all of those in one big bucket, and your front end has to figure out where each one is. Instead, the gateways can help direct traffic and form boundaries. They're also strategic places to put middleware, so you can bind tokens to your request or add metadata, stuff like that. And I have some examples of each of these. Like for discovery service, Eureka, Console are different services that are out there. Eureka's from Netflix, and Console is from HashiCorp. for gateways, you have type, Zool, express gateways, like that. So next we have load balancers. Load balancers are often used with monoliths too, but they become even more prevalent in microservices. And the basic goal of a load balancer is to distribute load evenly. So one of the advantages for microservices is being able to scale horizontally. So having many instances of one type of service. And so load balancers help distribute the load. So you put a load balancer in front or load balancers in front of an instance or instances, and it will distribute network traffic across all the instances. And finally, we have containers. So containers, how many here have heard of Docker? Almost everyone, cool. So Docker is one container system where you build some image and then you can run that image anywhere, and it will bind a filing system and run the image on a Unix process. And so it takes away environmental issues such as like it worked on my machine, but doesn't work in production because it's different. So it really helps with developing microservices and deploying them and all of that. There's also things like Docker Compose, Docker Centurion, where you can choreograph standing up all of the instances and the configurations are streamlined with those sorts of things. Okay, so just some key terminology there. So I have developed not a reference architecture, but a testing reference architecture for microservices, call it a microservices sandbox, to help in hands-on training. So tonight's a little too short to do anything hands-on, so it's a really simple a set of services around the banking domain, and there's two subdomains: the people domain and the account domain. And what I meant by it's not a reference architecture, it's not a reference architecture for implementation. It's not production ready. It's not probably the architecture I would use to implement this, and there's a lot of contrived things that I put into the system to bring out test cases or different use cases for testing. So it's a kind of a test reference architecture. And so, like I said, there's two different subdomains here. We have accounts and people. People takes care of things like updating people's addresses or logging in or making new users, things like that. And the accounts takes care of the bank accounts. And so here you can see that there's three APIs under each one, or three different microservices. On the account side, we have account command service and account query service. How many people here have heard of CQRS, command query responsibility segregation? Not many people. So it's a fairly complicated pattern or architecture for distributing events across the system and using event sourcing and separating your reads from your writes. Not really going to go into it. We can talk more later if people have questions on it. But these two services, the account command service and the account query service, implement that architectural pattern. And then we have the account transaction services, where all of the account logic for transactions live. So withdrawals, deposits, transfers, things like that. And they're wired to databases. They communicate via HTTP and through gRPC, which is a remote procedure call protocol that's very popular. Axon server uses that, and that's an event store. That's all part of that CQRS system. It distributes events all over a message bus, essentially. And that message bus is facilitated by gRPC. Okay, so you'll notice that the command services don't have databases. That's because they have an event store where they store events rather than entities. There are entities there, but they look a little bit different than you would see in a traditional database. Any questions so far on any of this? Cool. Now at the top of each of these domains, we have gateways and discovery service. So remember I mentioned before that gateways do all the routing and everything. The entry point to this domain is through the account gateway, and that will route all the requests to the various services. And you can set up all kinds of complex routing, like writes go to one service, reads go to the other service, or do a power route name, things like that. And then we have the discovery service so that these guys can find each other. And so the basic anatomy of one of these services looks a little bit like this. This design was borrowed from Martin Fowler's testing microservices. I forget the name of the presentation, but he has a slide deck on his site called something testing microservices. And here we have our service in this blue box. So this is kind of a logical boundary that makes up one service. And that service is composed of various components. At the top, we have the resources, which is the protocol or the API that's used to communicate with the service. We have the domain, which has all the domain logic, things like check if the balance is negative before doing a withdrawal or something like that. And then we have the repositories that map our entities onto the database and do all of our database mapping stuff. The gRPC client that communicates and consumes or produces events, and our HTTP clients and gateways that communicate with other services out there. Which brings us to these gray boundaries, which are network boundaries. So our binary here for this service runs on a VM or a container or another server. The database runs somewhere else, and then our external services and the event streams all live elsewhere as well. But what makes up our service is this blue boundary. And some of the tooling I use here. So not advertising these tooling or tools as being some of the best there. I use them for a specific purpose, and that was for the training. Those purposes were so that I could make something that doesn't use a lot of memory, so that anyone can run it on a laptop, and also stands up very quickly and simple to implement. So that's why I chose these, not for any other reasons really. Micronaut, I'm using in replacement of Spring. How many people here have used Spring before, seen Spring? 2 people, wow. Okay, so Spring is a very large framework. It's like the kitchen sink of frameworks for Java. It does all kinds of stuff. It has a data layer that can set up your data models and interface with databases out of the box. So it has a lot of stuff to help you skip writing boilerplate code. It has a whole web layer around APIs and writing stuff like that. So it's a giant framework. It does use a little bit of memory, so that's why I went with Micronaut. Axon is the CQRS framework here for doing all of our event sourcing and CQRS stuff. Console is what I'm using for the discovery services, using Express Gateway for the gateways, and MongoDB because it's really easy to drop objects in. And then JUnit is probably the most well-known testing framework for writing automated tests, so that's what I went with JUnit. Okay. So this is an activity diagram of what happens when you issue a withdrawal call or a request to the account domain. So each of these swim lanes here is a different service. And when you hit the gateway, that forwards your request to one service. That service does a few things, and then that forwards the request to another service. And then after a little while, it ends up in events and distributed throughout. But you can see, I'm not going to go into detail, and I know you guys probably can't read everything going on here. But one thing I want you guys to see from here is all the network activity. So any of these horizontal lines is network traffic. So from the outside, it looks a lot like a monolith. If I had Postman and I went and hit the account gateway and I issued my withdrawal, I can then do another request and hit the query service to the account gateway and get the updated account balance. And it looks exactly like a monolith with one major difference. Most of the time in monoliths, they're not optimistic systems. This one is. Because of the event sourcing and all of that, the system is eventually consistent in most of its actions. What I mean by that is when I issue the withdrawal command, through an API call, I'm going to get a 200 success message back almost immediately. That doesn't mean that the withdrawal command went through successfully, though. That just means that it accepted the withdrawal command. And then there's all of this that goes on in between there. And eventually, if everything is correct with the account balance and everything else, the transaction will conclude and the balance will be updated. So if in a few milliseconds after I issue that command, I then try to query the account, it may or may not have the right value just then. So it may have to hit it a few times. So that from the outside perspective, like doing a black box testing or system test, it looks similar to a monolith. But when you start to look under the covers, there's a lot going on. And a lot more that you have to test that you wouldn't normally have to test in a monolith. All these horizontal lines are essentially contracts between services, loose contracts though, that aren't enforced by any type system or anything like that. So contract testing becomes really important. And I'll show you a little bit about the contract testing shortly. Still no questions?
How do you ensure like if an error occurs? Like do you give them an ID and they can check on the transaction or something?
Yeah, so with the event sourcing systems and CQRS, there's something called a correlation ID that you can attach to your essentially a transaction or series of transactions. And so that way you can track the progress of that and you can check. And then there's different patterns that you can use to propagate that error to your front end or to wherever consumer positioning requests. Okay, so let's have a little demo. So what I'm going to do now, if I can find it, is just stand up the system really quick. So I'm going to use Docker Compose and just cat out one of these Docker Compose files. So Docker Compose is essentially YAML configurations that you can use to corral all your microservices together locally or out on some environment somewhere and stand them all up at one point in time, configure them all in one place. It's really helpful and really nice for testing things and doing things locally, but you can also use it out in like GCP and other places. And so here I just have configurations for each service set up where I can say where the discovery service is, where Mongo's at, what its port should be, all that type of stuff. So I'm going to use this script to just stand up a bunch of my services at once. So I'm going to Docker Compose.
Can you make it bigger?
Yeah. How's that?
Better. Thank you.
Let me clear it so it goes back up to the top. Still, can you read it in the back?
Oh, you good?
Okay, awesome. So Docker Compose dash F. So I'm telling it to stand up all the services. And I can see here it's getting all of my Docker images all set up right now. And then it's going ahead and starting up the services. So you can see Mongo, gateways, all kinds of stuff. It's going to be pretty noisy. But the other nice thing about Docker Compose running it like this is that you also get centralized logging. So it's taking all the logs, all the outputs from all my services, putting them in place. And we're just going to give that another few seconds. I think everyone's up. All right, basically what's happened is everyone's alive and trying to figure out where everyone else is and waiting on the discovery service and everything else. But it looks like everyone's resubscribing to the event source, so we should be good. Okay, so now I'm going to go ahead and issue a few commands. This probably needs to be expanded too. Shortcut doesn't work.
Oh, yeah.
How that a bug?
I like the color theme now.
Almost there. Can people read it in the back yet?
No.
Okay.
People in the front here. I.
Insomnia works great.
Getting close.
Okay, cool. So I think most people can read that. Yeah, it's about the same size as the terminal. No.
That's fine.
Man, I don't know why it doesn't work. Okay, so what I'm going to go ahead now and do is create an account. And so I'm going to issue a really simple JSON post to the account gateway. And the account gateway is going to forward that to the appropriate service, and it's going to make an account. Remember, this is optimistic. So when I do this, it immediately returns this account ID, but the account isn't necessarily there yet. It only takes a few milliseconds, so it's there now. But you have to remember that that's optimistic. And then I can come over here, and I can see that the account query service said that the account was created, and there's the ID. So where this was routed to was the account command service, but once the account command service created the account entity, it then emitted an event that the account query service was subscribing to, and it picked it up and it created an account for the same account in its database there. So we can see that all went just fine. And there's also a little bit of noise from a log there. Okay, so now I'm going to do a withdrawal or deposit, sorry, on that account. And this gave me immediately an ID, and this is a transaction ID that immediately came back. But that transaction didn't necessarily happen yet, although we can see down here that the account was credited, everything else had actually completed. But when at the point in time that I got that success message, it may have not been. So I know there's a lot of noise in these logs, but you can see that the command service handled a credit command. The query service then credited the account, and then the transaction service also marked the account as credited in the transaction. Because remember, each of these services has their own database, so they're going to have to update each of their own sources of truth for things based on the key source of truth, which is the account command, where all the events are emitted from for this particular domain. So that's just a little demo of how the whole system works. How you can stand holding up. Now to get into the testing. I'm sure everyone was wondering, okay, it's going to show me how to develop microservices or something, not test them. So now we're going to get into testing. And so here's a test pyramid showing the distribution of tests for this particular project. And I say the distribution of tests for this particular project because this is one of many pyramids or hourglasses, or somebody recently, is Jana here? No. Somebody recently told me cake was the latest style pyramid, a slice of cake. That was interesting. But you can have many different shapes, and it really depends on your use cases, your business domain, and all that stuff. So note also that exploratory and system testing are missing. You should do them. The reason they're not here is because they're outside the scope of what I want to show here. So we're not going to focus on them. So that allowed me to make the pyramid bigger. But exploratory testing, system testing should be there too. One of the reasons I'm not going to go into them is exploratory testing or doing some form of black box testing looks very similar. You're going to go to the front end, the website, and or the mobile app or whatever, and you're going to test it. It's going to look a lot like testing a monolith. There are some key differences, like if you're doing fault tolerance testing or performance testing, that may occur there, but essentially they're very similar to testing models. So at the very base, have unit testing. I'm sure everyone expected that. That's pretty standard. Monoliths or any code needs unit tests. We have class integration testing. And then we have something a little different. Service isolation testing, contract tests, and service integration testing. So that's where it starts to change when it gets into that magenta type color. And we'll go into those shortly. Any questions about this? Okay, so first off, I'm going to kind of breeze through this one because I'm sure you guys have all seen unit integration testing. We're back to this diagram again. We can see here that the unit and integration testing are focused around the resources, the domains, the repositories, the code your developers or you write is what's tested here. All the third-party stuff that we kind of isolate away, usually the unit test and integration test. Those might come into play a little bit more, but definitely the external stuff is not going to be there in those types of tests. Right, so not much difference there, your usual stuff. Here's where it starts to get different. We just jumped up to the magenta in the test pyramid, or the purple, depending on how you look at it. So the service isolation testing. So this is where we start looking at API testing. And where we have a need to determine some quality metric about the service before we start to deploy it and mix it in. Because if you went straight from unit testing and dumped this service into some environment with 300 other services and then started running tests, probably going to get a lot of flakiness, right? You don't know if even this service is working right, and what if everyone else is putting their services in that environment in the same manner, just running some unit tests. You could have a lot of flakiness there. So instead, we do some service isolation testing where we've mocked out all the external services. We've mocked our event streams so we can control all of that and exercise many different conditions on the service. And even here, we're using an in-memory database instead of the actual database. Recently at Hyro, I think you mentioned this, that we had issues internally in the company with using in-memory databases when it comes to relational databases. I think it was Maria.
This was when we were using Mongo, but the same
Oh, it
applies.
was Mongo? Okay.
Yeah.
Where the in-memory database was actually different from the external database. So there was issues there. So use at your own risk. But by using an in-memory database here, we can actually run these types of tests where the whole system, the binary is stood up, and we're actually hitting the APIs like a unit test. Just using something like rest assured and JUnit, you can hit the API with nothing else being up. So it makes it really easy to fit into any type of pipeline. You don't have to worry about deploying this somewhere or having the different dependencies live. So you get really fast feedback on a really nice kind of integration test of the whole system. But you can also tie this type of testing in with the database. So just have a database deployed, run your binary, and then start testing the service in isolation from everything else. So in the GitHub project, the reference architecture, I'm using something called WiredMock standalone servers to mock out all the dependencies. And I use Docker Compose, like the configuration I stood up just a little bit ago, to stand up all the mocks for a given service. And you can automate that as well to just mock out all the services and then deploy them. And so in this way, I can put entities or whatever I need that this service depends on in different configurations. I could give 404 errors, all that type of stuff to exercise this service under different conditions. So any questions about service isolation testing? Okay, so next we have contract testing, which I alluded to earlier was really important because you saw all those horizontal lines where all that network activity was going. And so for this particular project, I wanted to be able to run this really quickly and stand it up without any of the external dependencies. So I loaded mock repositories into the binary. And this allowed me to instrument the system into a certain state, the state that I wanted to be in. So I could hit all the different types of contracts. I could generate a bad request. I could generate a 404. I could generate all different types of things. Have lots of accounts returned. Have one account returned. Have no accounts returned. By just instrumenting this mock. To create these contracts, I'm using something called Pact. And Pact allows you to also set up a complex state management and things like that with kind of like a before test and after test type hooks. But that can become really complicated. Say you have like 50 different services and you have nothing mocked here, nothing isolated for your contract test, and you just throw all these services out there. You then have to instrument a lot of different states for all these different services. So like to give an example, say you have service A and service B. Service B calls an endpoint on service A. And so you're running your contract test on service B to make sure some other endpoint's working okay. And that's going to hit service A. That starts to introduce a lot of complexity and a lot of maintenance overhead on the testing. So doing something like this could help to alleviate that and scale a little bit easier when you're starting to get into like hundreds or even thousands of microservices. But you don't have to do it this way. There's a lot of different ways to do it. Like anything in computer science or the loose definition of microservices, there's many different ways to do it. And it really depends on what your needs are for this. Has anyone here read the book, Building Production Ready Microservices? Okay, good book. Some people disagree with me, but it's a good book. But it's written by somebody from Uber. And so what kind of problems does Uber have? Well, they have a lot of users, and they have a lot of users constantly hitting their app and their backend. So they focus a lot on availability and scalability and performance, and they also don't have a lot of long-running jobs. For the most part, they usually have shorter-running jobs. Whereas here at Ultimate, maybe we have longer-running jobs and less users that log in less frequently. So we have different sets of problems, making for different test cases, different types of user journeys, different architecture of the system. And so the test infrastructure and everything else looks very different between what we have and probably what Uber has. Okay, so the going back to the contracts and those horizontal lines from those swim lanes we saw in that activity diagram, contract testing is what allows us to make sure that that loose coupling is actually correct, that the providers are actually sticking to the contracts that the consumers are expecting. And so one pattern you can use is the consumer contract pattern, where each consuming microservice, in the case I gave with service A and service B would be the consumer, can write their own contracts, and then those contracts can be executed in a test against their providers. So in that case, it would be service A, and so you can make sure that it is valid and correct in that manner. And so you can use something called the packed broker, and this is a screenshot of what the packed broker looks like, to generate tests in very many different languages. I think, at least I've seen it in Java, Go, Node, Ruby, C#. I think they pretty much have every major language out there. So you can use packed to write tests, and then you can use something called the packed broker to have the consumers ship all those contracts that you've written, all those contract tests, to the broker, and then you can query based on the provider of those contracts to pull down all those contracts and run them against a specific provider. So in this case, let's say you had the account transaction service writing two consumer contracts against two different providers. Well, those contracts for each provider can then be executed against the actual real provider to make sure the provider adheres to it. So if you scale this and think, okay, 200 microservices, and 50 services are talking to 50 other services, that gets really crazy to manage if you do it outside of something like this. Looking at those loose contracts or that loose communication or loose coupling between services. So this helps you ensure that you have a lot of correctness there. So that's the packed broker. So this is a network graph of what the packed broker builds afterwards. So we can see that the account command service depends on the people detail service. The account transaction service depends on the people detail service, and the transaction service also depends on account query. And if there's contracts there, making sure that all those different providers are adhering to what was expected of it. So you can imagine if cross-team interactions as well. So say the people domain was a different team, and there was 20 other teams like that out there, and they all depended on something that was in the account domain. So how do you ensure that you are not breaking anyone when you change one of your contracts with your providers? This is a great way to do it even cross-team, because you all ship it to one packed broker. Any questions with contract testing?
I had a question mark on my forehead.
Oh, okay.
No, is this generated by the pack broker?
Yeah,
When
so
the tests are
the
executed?
packed broker,
So it'll show you those relationships?
yeah, so you would go ahead and write, like, it looks like a JUnit test or anything else, a contract test in your consumer. So let's say like the service B, you're consuming service A with some call. So in service B, you would write, like, let's say 5 or 6 contracts, and then you would just post those to the broker. And there's tools to do this, you just wire it all into the pipeline. You would post those to the broker, and then when you go to the broker, you would see something like this. Like, let's say this was service B, account transactions, and service A was people details. You could then, in the people details pipeline, you could query the packed broker for all the contracts from anyone who's posted any, and then run all those contracts against people details.
I'm assuming your diagram is simple, for presentation purposes.
Yeah.
But do those lines ever look like spaghetti?
Yeah, they can get really crazy. Like if you imagine there's 200 services, you're just gonna have a mess. But you can actually filter them based on the providers or the consumers to see a more limited subset as well. I think we developed something in-house, right, Pyro, that has a better graph too?
Yeah, for one of the projects that we worked on, we had about 150 microservices, and that diagram didn't scale well, so we ended up building our own internal pack broker. That helped us visualize that a whole lot better.
Yeah, but there's lots of open source stuff around Pack. It's pretty popular. So there's a lot of tooling out there too for wiring this all up, like I said, in the pipelines and everything. All right, in the back.
A question a little for the presentation a little bit earlier. So you were mentioning that you're mocking external services, right?
Yeah, on the
So-
service isolation tests.
So I'm wondering what happens if this external services are changed basically and you mark everything past as you, right? Because you mock the data, the external services. But then when it's hit it in real life, then the issue might happen.
Yeah, so I'm going to get into service integration testing soon to show how to look at that. And hopefully that would get caught in your contract testing if you like made a change to the contract. But if it was actually a logic change and the contract stayed the same, but the behavior changed in the service, then your mock was still returning the exact same result. And that's going to be a problem. And so you wouldn't catch that until your integration test phase, which is probably much further down your kind of test infrastructure. And may run once a day or may run much later. So you would like to get that in your service isolation testing, but you have to come up with a scheme to update all those mocks. And if you have too many of those mocks, they become really hard to scale. So if you have like 200 services and let's take a small subset, one service makes calls to like 10 other services. And so that for the test, isolation test for that particular service, you have to have at least 10 mocks there that gets up to date. There's different ways you can do that. Like you could make the mocks be maintained within the particular service that they represent, so that you only have one set of them and you can update them that way. There's different things you can do there, but there's still always going to be a little overhead if you start getting into that type of mocking, and depending on how much you do it. But that also might point to architectural problems with your microservices as well. With the way the dependencies are set up and things like that. Maybe you should use some more event sourcing and consume events with simpler contracts or something. It's really hard to go specifically into anything with this stuff because it really depends on your architecture, your domain, and everything else. There's a lot of different solutions you can use. Did that kind of answer your question?
No, I mean, that's fine. I'm just trying to see if, like, from point of view of my application I'm working on. So there's a lots of like external calls we make. So I'm basically collecting all the data and providing an output. So
Yeah, like if you
marking
do
is
like
not the option. It's there, I believe. So
yeah. You said there's another option there?
I don't think that's the option for marking there because they're like basically in the service that our team providing is like collecting all the data from different application, the teams in our application. So it's like, and we always see like someone deploying, let's say, or changing something for their part of the application, then it might break our stuff. And then if we mark everything, we would never catch that basically.
Yeah.
They are independent. That's why I asked.
Yeah, I mean, that's even one of the limitations of mocking at the unit, like doing unit tests and mocking too much, is eventually, what are you testing anymore? And if somebody else changes all their stuff, is your test even still valuable at that point in time? So there's trade-offs there, and definitely it sounds like for your situation, all that mocking wouldn't work. Okay, cool. So that kind of leads us right into service integration testing. So good question there. So here in this diagram, I'm showing integration testing at the subdomain level. So this is the account domain, shown with a little bit different view, and we're mocking the people gateway. So remember that's the ingress point to the people domain. And so we're mocking essentially all of the actions of the people domain here. And this looks like a big pile of spaghetti, right? There's a lot of complexity, a lot going on here. So that's kind of one of the reasons why I was alluding to, hey, if you just do unit testing and throw your services out here and try to integrate them, you can run into a lot of flakiness because there's so much complexity and so much going on here. These tests can also take a little bit longer to run and that sort of stuff. So we have the entry point here being the account gateway. So here, all the tests in this project are run hitting the account gateway API, and then to instrument something to cause some action, and to also set up the system, and it's also used to verify the system as well. So much like it would be used in a real case or something like that. So we have the discovery service and everything here. We can see all the network boundaries set up and all the traffic going. So yeah, there's a lot of moving parts, a lot of complexity, and that's why we want to get some of the contract testing and service isolation testing to catch some things before we get here and have to have this out in the environment, because also debugging here becomes a lot more complicated. You can do a lot of really nice logging infrastructure to this to help out with debugging and monitoring and things like that, but it's still more complicated, I would say, than a regular monolith or something like that. And so integration can be or is hard. So that image I just showed you looks a lot like a graph, right? So if I gave you this graph and said, how many tests do you need to cover all the permutations here, how many tests can you come up with? A lot, right? Testing every single connection between everything. But do we really need to do that? That was kind of a trick question. We found we have a lot better success doing user journey type testing here, where we're testing kind of our customers' kind of workflows to the system at this level, rather than trying to test everything, because we would hope that all of these different connections are validated by our contract testing. So we just need to enforce really good contract testing, and then we can look to see that the contracts are adhered to. And then if we set up enough coverage on our user journey tests, which are going to be a lot longer, we can hopefully hit all, or we can hit all of different points. Okay, so now comes the question. I showed you this whole pyramid, showed you all these different types of testing they can do with microservices, but how and where do you run them? How do you execute them? That sort of thing. Well, just as with everything here, squares and circles don't match up. There's no one size fits all, but here is one potential way you could set all this up. So here in this diagram, an engineer commits some code, the new code to a service, and immediately the pipeline picks that up and issues a pull request and also starts building that code. Once the code is built, then our integration tests and our unit tests and building the Docker image can all kick off. Once the Docker image is done, we can start to run our contract test and our service isolation tests. And once all of this is done and the pull request has been approved, maybe we can go ahead and deploy this service and then run all of our integration tests. And then after all those pass, we can then move to exploratory testing or put this out in a staging system or something like that. Now, this is probably not the ideal, the most ideal for this project, but it's very simple to represent. Maybe I would make the pull request after the build or something like that. Maybe the service isolation tests can happen alongside the unit tests without the Docker image. There's different ways you can do it. But this is one simple way you can structure this in your pipeline execute. Yeah.
In this diagram, so the same engineer commits a new code. Are we assuming that he also made a unit test for that, or there should be like made after?
Yeah, you can hook code coverage metrics up to this and also have the pipeline check that there's not zero tests for things, that there's a one-to-one mapping. You can do all kinds of stuff there to ensure that these are adhered to.
I mean, if let's say I look at it from CI/CD point of view, I would assume we may streamline it to production or whatever if we're still confident in the test. But then, are those tests going to cover? Let's say I build a new feature. Are those tests going to cover that?
And so you could tie code coverage metrics into this and say, okay, well, if you're not at 85% code coverage, then this pipeline fails. And also in the code review, your engineers should be checking to make sure that new feature has the proper test in it. Depending on, you can have different rules and or like some type of guide for your pull requests. And then you can also do other things like making sure there's like one-to-one mappings for unit tests and classes. There's all types of different techniques you can do to ensure that. Which kind of was what I was going to get to. You keep predicting my next slide. So standards, herding cats. So herding cats is a futile attempt to control that which is inherently uncontrollable. So this shouldn't be like herding cats. You should have standards. Most modern pipeline systems have templates that you can create and you can just copy. And so one of the things I find that works really well is doing CI/CD first and TDD on this. So setting up your pipeline. So you don't even have code yet. You set up your pipeline template for a new service, and then you start coding. And using TDD, you start coding to make that pipeline green. It won't be green because maybe it doesn't have code coverage, or maybe there's no tests in your service integration tests or whatever there. So you should definitely have standards. And those standards are going to vary from project to project and look different and vary from team to team even. But they're very important to keep all this in line and not just everyone going out making their own thing. And because a lot of times microservices are advertised like, oh, you can make any service with any language. So you think, oh, I'm going to make this service with Go and that service with Ruby and this service with Java. Well, you need to make a pipeline template for each one of those. You have to set up your logging, your infrastructure, all of your monitoring, all of that. There's a lot of overhead there. So standards in general are really important with microservices to kind of keep all of that overhead, that infrastructure that's required, all that development manageable. But it's also really important for the testing to make sure you are getting all of the layers of your pyramid in each and every service across each and every team. Okay. And there's some other testing that I haven't really gone over and that I didn't have in the pyramid, but it's also important here. So all these are cross-cutting, so performance, availability, scalability, fault tolerance. There's a lot of really interesting testing that you can do that I don't know, I really have fun with chaos testing. Has anyone heard of chaos testing, Chaos Monkey? A couple of people, okay. So it's where like you deploy some other service or framework in your environment that randomly shuts off services and things like that, and then you can check your fault tolerance. So does the application as a whole still mostly work if you shut off services X, Y, and Z, and that sort of thing? So they're interesting experiments. And also, one more thing is don't cross monitoring and testing or vice versa. So a lot of times you'll be tempted to set up scheduled tests that run and they check something all the time. Well, maybe that's better for monitoring, or maybe you're trying to monitor something that should be actually tested. So you want to be careful not to mix up those so much. But those are my closing remarks for you guys. Any questions or anything?
What CI do you use?
CI, so we use 3 different CIs. We use Concourse, TeamCity, and Jenkins. So it depends on the team, when they're set up, and everything else. I like Concourse the most because the templates are just really nice.
Mhm.
You can just kind of copy and paste them from project to project. But some people like the GUIs more, and something like TeamCity or Jenkins.
Circle, you ever heard of Circle CI? I
Yeah, that's a cloud solution, right?
think so. But yeah, they do Docker images as well with YAML. So nice.
Yeah, that Concourse, or actually we have, it's plugins, right, that we use, Patrick, for Concourse to do all the Docker stuff? Yeah, okay, so we made ours pluggable and tied it Docker to that, but yeah. Yeah, any other questions? Nope, okay, so if you guys are interested in the project, all the diagrams I showed and instructions on how to run all the tests and example tests, as well as some guides on how to create the tests, are all in this URL here, which is linked to this QR code. There's 2 guides. There's one for creating contract tests. So it'll walk you through how to create the contract test, how to upload the contract test to the Pack Broker. It includes a Docker image for that Pack Broker that I showed the screenshot of. And then it will show you how to execute those tests and retrieve them from the broker on the different providers. And then there's also a service isolation guide on there for creating a service isolation test. So it walks you through how to create the mock. I use JSON to create the mock requests, and then how to inject those into the standalone servers and execute those tests. So if you guys don't have any questions,
Yes, I have a question.
oh yeah.
And when you show the accounts, you have the client and the account. In the account, you have multiple microservices there. Each of those microservices you have hosted in different Dockers, or that is one microservice?
No, yeah, each of the little diagrams from the first slide, or not the third slide or whatever, are each a different Docker container. So account command, account query, and account transactions are 3 separate Docker images that run as different Docker containers. So I guess we can have some more networking. I was expecting some more questions.
I have a question that it feels like a sort of a curiosity, maybe outside the scope of what you really wanted to present. But I was curious about just microservices as a communication tool, a way to connect and exchange data. What kind of security concerns should you keep in mind, or what kind of vulnerabilities exist? And the reason I'm asking the question is because of like SQL injection and other things that we had traditionally tested for. And are there vulnerabilities when you start using microservices that you need to consider?
Yeah, for sure. There's a lot that you actually, I missed a bullet point here, security.
I found a bug.
Yeah. I just realized that actually when you said that, I was like, I don't have security. That should be the top one up there. Is security. So yeah, the security can be really complicated too with microservices. Like when you start to look at authorization and dependency and things like that, where you have to encrypt all the lines of communication between things. Hopefully you've created a extensible enough and robust enough message bus or communication layer so that you can just slap something on there, not slap it on there, but create a really nice security layer on there that you'll then need to test and everything else. But when you're dealing with different authorization levels for different services and all of that, that all needs to be managed and really thought out and architected. There's different ways to do it, but it is quite a bit more complex than dealing with something that's in a monolith where you can just say, hey, you can manage all the endpoints from one configuration file or something like that.
What I was thinking was if you were an engineer I was working with and you gave me work to test, what method might I try to perhaps infiltrate or break or get into that exchange of data that you've given me to test? Aside from, you should have those things there, but none of us would be here if it all worked perfectly. And so I guess I'm curious if there are different things that I could try, or different methods that I could try to sort of test the security or get around and access something I shouldn't access.
So you're talking from like the black box perspective?
Yeah, because if I know what's there, and I'm gonna test what's there, but if I'm a user, if I'm an ill-willed hacker out there and I wanna try and get into a system and where I shouldn't be, or if I'm testing your work and I wanna try and break that, what types of ways would you use?
I would say everything you already know for black box testing would still be relevant because at that level, the system looks very similar to a monolith. Because you're not
So
seeing.
I'm still gonna have the
you're going
same front
through-
end, I'm not gonna know what's back behind.
Yeah, you're going through a gateway or gateways, so to you, it looks like a monolith.
Okay.
Just an optimistic monolith where the system's eventually consistent with itself. So
Mhm.
maybe the actions don't immediately return. Like if I created an account, it doesn't return back the entire account that was just created successfully. You might have to wait a few milliseconds or seconds for that to occur. But from the black box perspective, not a lot has changed. Like if you have, I was using Mongo here, but if you had relational databases, you're definitely gonna wanna look for the SQL injection, things like that. Even throwing things like GraphQL and stuff like that on there, which can limit certain types of JavaScript-based attacks. you still need to check for SQL injection on your field
Okay.
level and things like that. So all those techniques, like checking the different authorization, so I'm going and looking at feature toggles or something in the system and the authorization, and I want to check the authorization or something like that. It's going to be very similar.
So a lot of those same black box techniques still apply, and it sort of doesn't matter what's
Yeah.
behind it. Even though I know what's back there, I'm still gonna try different ways to get around.
Yeah, so like if you're testing with Postman too, you're probably hitting a gateway. So that's kind of what I was alluding to in the beginning with the activity diagram. It's going to look a lot like testing. You're probably not going to use Postman when you're doing some type of like system testing or something like that, or exploratory testing, and go and hit all the individual microservices, because that's not really representative of how the system works.
Right.
Because maybe you got the order wrong when you hit the 20 services you need to hit for some action to occur.
Now, if you have the luxury of, say, running all your microservices on your machine, like on your local machine, you could use something like maybe Wireshark to see the communication
Yeah.
between all the different microservices. If you're checking to see if maybe everything's using SSL or TLS, something like that for security testing. So that's something that might be useful.
That's good to know.
Yeah, and then in production, there are tools like Zipkin for tracing requests through the various different services, which can also help with security testing.
I've been working on a project recently where I felt like I was sort of on my tiptoes technically. And it was performance, but performance, we've done some testing specifically on the service.
Mhm.
And then some black box testing just through the GUI. And when you press the button, you don't know what's going on behind, but trying to analyze that and take apart, like how it's working and how to make it faster. And so some of those questions around that sounds like something actually.
Yeah. Doing that lower level testing, like Dione was mentioning, there's also service meshes are becoming really popular for microservices. And your service meshes has all kinds of built-in monitoring on communication and everything that you can set the flag, hey, this transaction wasn't encrypted and things like that. So your monitoring might also pick up, your monitoring tools that pick up that sort of stuff.
That's good to know. Thank you.
Even some service meshes include encryption automatically.
Yeah. They do all the security, all your communication layers, take care of it. Any other questions? Going once, going twice? Okay, so I guess we can do more. Oh,
I'm sorry.
Do I need to ask for it? Yeah.
So you're saying you're using, you're mocking with JSON, for, all your endpoints pretty much?
Oh, so, WireMock allows you to create JSON files, chuck them all in a directory, and then point a Docker image, or map that Docker image, map that directory to a Docker image. And then when the standalone server, the WireMock standalone server stands up, each JSON file will be a representation for some endpoint to hit. So if I have like two endpoints, one endpoint actually,
Yeah.
with two different IDs as the final parameter on it.
Right.
One of a user that doesn't exist, one of a user that does exist. So I can make two different JSONs, one that returns some structure that I define in the JSON of that user, and the other one that just has a status 404 on it. And then I can load those in that directory, stand up the server, and then I can hit the server on those two different URLs.
Okay.
Same endpoint, but different IDs at the end.
Yeah.
And it will give me the different responses. You can also do it on a standalone process using like JUnit and programmatically make those mocks. So if I'm writing some JUnit test, like a service integration style test, where I'm going to hit the API of the service under test, before that, if I know what endpoints are going to be hit for other services, I can configure those services programmatically, saying like, given this URL is hit, then I return this with this status. They have a nice PDD syntax, behavior-driven style.
Okay.
Where you can define all of that, and then you can inject that into your discovery system client on your service under test, so that it will go out and automatically query that URL, but it's still all running off the same unit test or JUnit process that's running, and then it'll hit the mock. You have the whole thing mocked out, so that might be a little easier too than having your own standalone servers.
You ever heard of a JSON server?
Yes, it sounds familiar, but I can't think of it off the top of my head. There's a lot that do this. Like there's something called Hoverfly that will actually monitor.
Wants the server for you,
Okay,
pretty much automatically creates all the endpoints for you.
cool. Yeah, there's something. So Hoverfly does something similar.
Without all the extra.
Yeah. And there's other things like Gremlin has a plugin that will a system called Gremlin will have a plugin that watches your entire like subdomain, all the traffic going on, and then you can go ahead and generate locks for all of that based on what happened, and then you can run one service, shut all the others off, and it'll still
Gremlin, right? Yeah.
So there's a lot of tooling out there for that. We could go on all day with the tools. Okay, so if that's it, then I guess we can go back to networking and pizza.
Cool.
There you go.
Thanks, guys.